Okay, I'm using mine as well. So the very first value is what? The very first value is, let me see, 8.8. Then we have 12,000. And in the last, we have 5,700. So what are you getting? Okay, okay, okay. It's, I guess, six. For me, it's 601. 8, yes, because we are moving it 8 times. So mine also was 601,920,000. Okay. So when we convert it, it becomes 6.01 into 10 to the power 8. So this is the total uptake of carbon dioxide in a given area. That is 12,000 meters square. Okay. Let's move to the next question. Where is the next question? So again, the figure one shows that there is a small difference in the mean uptake of carbon dioxide between 830 to 940, where a graph is given. So there is a very less difference if you look at this. Okay. So state what this p value tells you if about the difference if it is more than zero point 0.5 because of chance. Correct. So this, okay. Again, we have a question. Okay, in this species of a tree, very high light intensities can inhibit the release of electron from the chlorophyll. Use this figure to explain. Now you have to give the data that over when we increase the light intensity from 830 to 1140. Now here the light intensity is more. Definitely, it's that time of the day where we have more light. 1140 to 115. Are you getting me? Okay. So, what can be the reason that there is inhibition of the release of electrons from chlorophyll? Okay, it's more related to the limiting factors. You're telling correct, but it's more related to limiting factor, first of all. So when the light is like too high, definitely there would be lesser. So okay, there comes a point when it become lesser, and if the temperature is very high, the stomata are going to be closed. Very first thing that comes to mind. Okay, now let's go to the production of ATP and NADP. Now tell me the answer. Okay, okay, okay. So ultimately, there would be like lesser uptake, and the reaction rate is less because already they're not uptaking the carbon dioxide. Okay. Let's move to the next question. The tomato plants grow best in high light intensities and even high carbon dioxide concentration. To increase the yield of tomato, uses LED light bulbs to provide additional light. To increase in dry mass D produced, sorry, I'm copying pasting it. D produced when additional light can be calculated using this formula. L is the light used and F is the GPP is converted to NPV conversion factor for tomatoes. The table below is given. Now use this equation to calculate the increase in dry mass produced when LED light bulbs used. Wait, let me copy it. Okay, so we have the values for F and we have values of L. Can you just divide them and tell me the answer? Use this formula which is already given. 87 10 raised to power minus 2 divided by Wait, you need to, because if you do it directly on the calculator, it will show error. So first of all, multiply 0 0.4 into 2. Oh, so, sorry, 20 into 0 0.4, 8. Wait, it would be, yes. And now do it. Yes, minus 2 divided by 8. Okay, convert this into significant figure. The answer, my answer is 0.00359. Let's round it off. Okay? Is your answer the same? Like 5875. Okay. Now let's convert this. Moving 1 here, 2 here, and 3 here. So 3.59 into 10 raised to power minus 3. Okay? Now the units. What would be units? Just divide them and tell me the units. Okay, the units are this. I'm writing here for joules per meter square, or this one, minus 1. Are you good at maths? No, you once told me. Okay, this m and j are cancelled. Now, what would be the units of this? It would become, let's do it, m minus 2, h minus 1, and this kg, when it moves to the denominator, it becomes plus instead of minus. So this is kg per meter square per age or per hour. Okay? Keep in mind, whenever something is in the denominator with some exponent which is negative, it has negative 1. When it goes into the numerator, it becomes positive. So I'm doing this calculation part for you so that you'll be able to understand, okay, how we do this. But this is quite simple because formula is given and you just have to calculate. There's no rocket science as this one. Okay, this is all. Let's move to respiration now.